It happened. SpaceX's 3D printed spacecraft is here. Elon Musk dominates the headlines for three reasons. 1, for his cryptic tweets. 2, his Tesla automobile company. And 3, for his cosmic space ambitions and SpaceX. SpaceX has been dominating the news recently for the rapid developments in the space sector. This time, it's about a spacecraft that they sent to space, and not your regular spacecraft that NASA sends to space and to their International Space Station. This spacecraft has its parts made by 3D printing. That sounds like a new talk of the town. So, does this sound interesting to you? Then the rest of this video is going to be even more amazing. SpaceX, a commercial rocket business, plans to carry astronauts into space in the coming years, and it will do so using a cutting-edge technique called 3D printing. SpaceX, located in California, is employing additive manufacturing, popularly known as 3D printing, to construct the emergency escape rockets aboard its new manned Dragon spaceship. SpaceX's entry in NASA's competition for commercial manned spacecraft to transport humans to and from the International Space Station is known as Dragon version 2. Earlier this year, SpaceX launched its first 3D printed component into space. The item, the main oxidizer valve for a rocket engine, sailed on board SpaceX's Falcon 9 rocket that launched the commercial TICOM-6 telecommunications satellite into orbit on January 6. The valve landed within one of the Merlin 1D engines of the rocket. The valve worked properly with high-pressure liquid oxygen, cryogenic temperatures, and severe vibrations during the trip, making it the first time SpaceX has ever flown a 3D printed part. Ever since SpaceX's 3D printing made it to the news, everyone has had their eyes on the same thing. The European Space Agency has considered using 3D parts to build lunar bases, and NASA aims to send a 3D printer made by California-based business Made in Space to the space station this year. Despite these ambitions, a recent assessment from the National Research Council stated that the technology is still in its early stages and that the material science driving space manufacturing is poorly understood. SpaceX has spent 3 years researching the rapidly evolving technology with a focus on its application on the Dragon spacecraft. In fact, in late 2013, a 3D printed Super Draco engine chamber that will be utilized in the escape mechanism passed a full thrust firing test. The Super Draco thruster engine is an improved version of SpaceX's current Draco thruster engine, which is used to control the Dragon spacecraft in orbit and during re-entry. The crewed version of the next-generation Dragon version 2 spacecraft will be equipped with Super Draco. They'll be used to power the spacecraft's launch escape mechanism, which is fully incorporated into the vehicle. When compared to typical machining, printing the chamber reduced lead time by an order of magnitude. In fact, the period from concept to first hot fire was just over 3 months. The 3D valve inside the Falcon 9's rocket engines will also be easier to produce, according to SpaceX. The 3D part has passed comprehensive testing and is now approved to fly alongside conventional spacecraft. A printed valve body provides higher strength, ductility, and fracture resistance when compared to a traditionally cast part, as well as less variability in material properties. In comparison to a conventional casting cycle of months, the body was printed in less than 2 days. SpaceX completed Super Draco certification testing in May, including repeated starts, extended firing durations, and high off-nominal propellant flow and temperatures. Each Super Draco can be restarted as many times as necessary. They can also deep throttle, giving astronauts massive amounts of power while maintaining pinpoint accuracy. The Super Draco engine was successfully throttled at thrust levels between 20% and 100% during the hot fire test, according to SpaceX. The engine was fired in 2 different profiles: launch escape and landing burn. During the hot fire process, the chamber was fired over 80 times. If a problem arises during launch, the 8 engines of the Dragon version 2 launch escape system will deliver up to 120,000 pounds of axial thrust to transport the crew to safety. The launch escape mechanism also allows astronauts to land the spacecraft with the pinpoint accuracy of a helicopter utilizing power. As a result, the Dragon version 2 spacecraft is totally reusable and can be refueled and reflown several times. SpaceX will fly Super Draco later this year as part of a launch escape system demonstration. In January, SpaceX's first 3D printed rocket engine part for the TICOM-6 mission was launched on the Falcon 9 rocket. A 3D printed main oxidizer valve, or MOV body, was part of one of the rocket's Merlin 1D engines. The valve worked properly with high-pressure liquid oxygen and was able to tolerate significant vibration as well as cryogenic temperatures. The printed valve body outperforms traditional casting in terms of strength, fracture resistance, and ductility, as well as material variability. It was also far quicker to produce, taking only 2 days to print instead of months. All Falcon 9 flights will now be equipped with a valve. Well guys, that's all for today's video. Comment below to let us know what you think, and don't forget to subscribe to this channel for more content. Thanks for watching, and we'll see you next time.